Hi, so I'm Anais Orsi, and I'm an assistant professor in climate science in the Earth, Ocean and Atmospheric Science Department at UBC. So next month I'm going down to Antarctica, the coldest continent on Earth. If I was going to describe my project in 3 keywords, the first keyword is katabatic winds, those fiercest, strongest wind on Earth. They're not, necessarily hurricane winds, but they're sustained, they never stop. So that's how they're different from, a wind gust that you would have. And second keyword would be ice and ice cores. And the third keyword would be the air. One of the key things that we are going to do is measure the air that is inside the porosity of the ice core. Because you can imagine an ice core is first snow, and in between snowflakes you have holes, and in these holes there is air. And that air actually has lots of things to tell us about the climate of the present and the climate of the past. We hope to find the oldest ice, like ice dating back to more than 1 million years. We care about 1 million years because something very funny happened between 1 million and 1.5 million years, is that before that, we had ice age cycles every 41,000 years. And then after that, in the last million years, we've had ice age cycle roughly every 100,000 years. But why did ice age cycle just shift from 41K to 100K? Mystery. And part of the key to that mystery is to have a CO2, a carbon dioxide record for that whole period. Ice cores are fantastic recorders of the past atmospheric composition, like I told you, because there's air inside the ice, inside the snow, and then it makes bubbles. And if you see a piece of Antarctic ice core, it doesn't look like ice cubes in your freezer, because there are all these beautiful bubbles you can see with your naked eye. They're like 1 millimeter big. And so those ice cores, they can tell us exactly what was in the atmosphere 1 million years ago. And we want to know what happened to the carbon cycle that maybe helped shift the pace of these ice age cycles. And that will tell us something about the interaction between carbon and climate. And today, with climate change, understanding better the interaction between carbon and climate seems like something worthy of investigation. And so we are bringing samples back with us. Most of our samples are going to be gas canisters we'll fill up with air, and so they're 3 liters, they look like this. And then we'll also bring a bunch of ice core samples with us. And then we also will bring some data from weather station data, from like really fancy instruments that are just numbers on the hard drive, and probably pictures. I have a comfort thing that I always bring. I bring a couple bars of chocolate. And the thing is, I keep the chocolate for a bad day. And usually, I don't eat it. Because there's never a day that's so bad I'm sure I'm not gonna need it next week, So I'm like, today, it's not that bad. I don't need to break the bad day bar chocolate. And so oftentimes it doesn't get broken until, you celebrate the end of the expedition. But it's a good thing to just say, is it a bad enough day for the special bar chocolate? Well, I'll bring several just in case, but that's one thing maybe, that I bring as a comfort item. Oh, I just love being in the field. First of all, it's beautiful. It's beautiful in a very special way that few people get to experience, because it's also very empty. In Antarctica, it's flat and white, and there's nothing to see, but the sky takes all of the space. And if you're in a whiteout, there's no smell, it's a completely foreign experience. But the other thing is human relationships, when you're a small group in the middle of nowhere with no communication to the outside world, is also strengthen human relationships, and that's also always something that's really cool.